Hello, I welcome you all to this another interesting screencast. We're going to be solving this engineering mechanics problem, and it reads the particle travels along a straight track such that its position is described by the position time graph. Construct the velocity time graph for the same time interval. So, solution. All right. So we have been asked to find the velocity time graph for the same time interval. I also include the acceleration time graph for the same time interval. All right, I'll include this as well. Right. All right. So we have the position time graph here from 0. Okay. The position of the particle to time is equal to 6 is being governed by this particular function 0.5 t to the power 3. And if you've seen the slope, okay, keeps on increasing, right? If I was to take this point, and that point, and I draw the tangents to these points on this curve. All right, let me use this straight line. So the slope here compared to this slope, that's 1 minute, to this slope, compared to this slope, and compared to this slope. Are you seeing these lines? So if I was to label this line 1, if I was to label this as 1, 2, 3, 4, what do you think is happening to these slopes? Slope number 1 is not as high as slope number 2. So we have 4. So 1, the slope at 1 is less than the slope at 2, and 2 is less than the slope at 3, and 3 is less than the slope at 4. So 4 has the highest slope. So we've seen how the slope keeps on increasing as we approach time at 6 seconds, right? Then from 6 seconds onwards, we have a constant position, right? S is equal to 108. What do you think it means? The particle in this time interval from 6 to 10 is not moving because we do not have any velocity. So these slopes that I was just drawing, slope at 1 and 2 and 3 and 4, denotes the velocity, because we know that the slope of the position time graph gives us the velocity. The slope of the time of the position time graph gives us the what? The velocity. Okay, velocity is equal to ds dt. So this is what I'm saying. And from 6 to 10, okay, in this interval here, we don't have any change in position. There is no displacement there. So it means this displacement is going to be 0. Okay, if you looked at point at 6 seconds and the other position at 10 seconds, these 2 points, they'll not give us any displacement, and therefore we're not going to have any velocity. Velocity is 0. Okay, we have 108 minus 108. So this point, if we name this point 1, or pick this point 108 minus this point divided by 10 minus 6, this becomes 0 over 4, right? Therefore velocity in the region 6 to 10 is what? 0. So we do not have any velocity. Therefore it means in the region 6 to 10 we don't have any velocity, and the particle is not moving. All right, so now let's draw. Before we draw, let's find the function that will govern the velocity in the interval 0 to 6 and from 6 to 10. So t from 0 to 6, been told to say our position that governs the position function is equal to 0.5 t cubed, and our velocity is going to be equal to ds dt, which is equal to a 3 by 0.5, a 3 by 0.5 t squared, which is equal to 1.5 t squared. It's quadratic, right? Then in the interval 6 to 10, our position there has been governed by a constant value, which is 108. And therefore our velocity is going to be equal to ds over dt. This is instantaneous. But then we know to say the derivative of a constant is what? 0. Alright. So having done that, let's now plot the velocity time graph, and we also do the same for the acceleration time graph. Okay, so something like this. All right, can I plot also in advance? Oh, sorry, like so. I just wanted to copy one so that I can also put it there. All right, so there we go. So I'll start with, of course, the velocity. This is the velocity. It is in meters per second, and this is the time. It is in second. And there we have the acceleration, which is in meters per second squared. All right, and there we have the time. All right, so let's plot. So the velocity is being governed by which function? I mean the velocity in the time interval 0 to 6 is being governed by this quadratic 1.5 t squared. So it's going to be quadratic, something like this. Sorry, it opens up. Okay, I may not have drawn it well, but it is something like that. All right, something like this. Okay, so what is this maximum point here? This point here. This point here is b over 6 at 6 seconds here. B of 6 is going to be equal to 1.5 by 6 squared. B of 6 gives us 1.5 by 6, which is 36. 36 by 1.5 is what? That's 54, right? Okay, so this is going to be a 54 meters per second. So this is 54 there, like so, right? Okay, maybe I give it a color. I give it color red. Okay, give it color red. So I'm going to have a graph like this. And then from 6 to 10, what is our velocity? 0. So we'll have 0 velocity there. Okay, we'll have 0 velocity. 0 to somewhere there 10. 10. So this is the graph that we're going to have, and this is being governed by, this is v is equal to 1.5 t squared. All right, so we are done with this one, and then let's find for acceleration, right, in the same intervals. So what I'll do is I'll just rub here. I want to use the same spaces. and I'll wrap there like so. All right, and also just wrap there, and the intervals I'll leave them. I'll wrap there, and also just wrap there on top like so. Yes. Okay, so we know that acceleration is equal to dv dt, and what is our velocity is 1.5. What's the first derivative of 1.5 t squared? This is going to be equal to a 2 times 1.5 by t, which is equal to 3t. Okay, in this interval 0 to 6. Okay, and what about from 6 to 10? So acceleration from also going to be dv. So from 6 to 10 we don't have anything, so it's 0 also there. All right, so let's plot. What is this one? This is a straight line, this interval, right? So we're going to have a straight line, so we'll have a straight line something like so. Make it a little bit thick. We'll have a straight line something like this. One will be much steeper, right? To be something like this, something like that, right? Yeah, to be steep, right? Because you're saying at 0 is 0, at 2 it is going to be a much higher value. The other side is 6. At 3 it is 9, and so on and so forth. Okay, so we have something like this. At this point is 6 seconds. This is 6 seconds, yes. In this point here, acceleration is going to be equal to 3 by 6, which is equal to 18 meters per second squared. So this is 18 there. And then the rest from 6 to 10 we have a what? We have a 0. No acceleration there. No acceleration up to 10. All right. 10 seconds. Okay. Yeah, so we're going to have something like that, right? We'll have something like that. I guess I'm done. Just want to put some dotted lines there, so that I was just trying to mark something like that. Yeah, so we are done. We found the velocity time graph as well as the acceleration time graph for the same time interval. Bye bye, and see you in my next screencast.